Welcome back, pre-calc students. Let's begin Chapter 3, Polynomial and Rational Functions. Most of the topics in this chapter are pretty well covered by college algebra, Math 1100, or even before that to a certain degree. So there's no reason for me to spend too much class time in this chapter. Instead, I'm going to concentrate upon 3 topics and breeze through the rest. Number 1, the reason why we can do the kind of things we have been doing in nonlinear inequalities. Zeros, multiplicity, sign analysis, and things like those. So far we had been doing all those algorithmically, but without much explanation. Now, why can we do that? Well, that question will be answered here in this chapter. Number 2 is complex numbers. I've been teaching college algebra or intermediate algebra for several years, and most of the time I never talked about complex numbers there, even though they appear in the textbook. Now we reached a point that I cannot postpone that any longer, so let's talk about complex numbers. And finally, number 3 is domains of algebraic functions, but that's going to be a long story, rather deep topic, so let's talk about it when it appears, probably at the end of this chapter. Okay, let's begin, and the easiest example here, the simplest, will be quadratic functions, and let's use our Mathematica notebook here and initialize it. Let's begin. This is really a skeleton version of section 3.1. The most important topic on quadratic functions, well, that's vertex form. This is a general form, y equals ax squared plus bx plus c, but you can complete the square and manipulate it so that you can get it in this form, a times x minus h squared plus k. You can do that by completing the square when a, b, and c are given, but that's rather cumbersome and tedious, so you can use this shortcut formula, h equals to negative b over 2a, and k equals to negative of b squared minus 4ac over 4a, like this. If you convert the general form into vertex form, then you can answer most of the questions about quadratic functions. Here's an example. When the leading coefficient, a value, is positive, then the graph is concave up, and we have to have minimum y equals to k at x equals to h. That's the vertex, h comma k. And the range is going to be from k to infinity. The lowest y-coordinate value is the y-coordinate value of the vertex, that's k. And then, as you can see, y-coordinate just goes up forever. So the range is k to infinity. What if a is negative? In that case, we have this kind of graph, concave down, and we have a maximum at y equals to k, at x equals to h. The vertex is h comma k, and that's the highest y-coordinate value you can get. So the range is negative infinity to k. And one more thing, I didn't write it over here, but the line of symmetry is x equals to k, and x equals to h, excuse me. I better write it down, by the way. Okay, here we go. Symmetric about x equals to h. That's a vertical line that runs through the vertex. And same for positive a case. And you can answer all these questions when you have vertex form. And when you have general form, then you can convert it into a vertex form by these 2 formulae. Now, there's another important formulae, maybe not as important as vertex form, but that one is this one, intercept form. Y equals a, x minus r times x minus s, when the y-intercept, the x-intercepts are x equal to r and x equal to s, or the zeros of the quadratic function. The first graph here, the blue one, is when a is positive. And I selected r and s values as negative 1 and positive 2 respectively. And the red one is when a is negative. For that one, I selected r and s as negative 1/2 and positive 5/2. We have to have symmetry, by the way, and symmetry is with respect to the vertical line x equals to h, or the vertical line that runs through the vertex. And here we have r and s as zeros, so h value must be right in the middle by the symmetry. R plus s over 2, the average value. Once you have h value, you can plug in that h value in place of x, and then you can find out what k is. For example, plug in x equals h here and also there, and you're going to find out k value by that kind of computation. But then again, intercepts do not always exist. In some cases, we may have some situation like that. And the blue graph in the left-hand side is the case when b squared minus 4ac is negative. Consequently, we have no real solutions of the equation ax squared plus bx plus c, which means no real zero. Not coincidentally, the graph is not touching or crossing the x-axis. The red graph you see over there is an example of a double root. When we have k value 0, then we have y equals to 8 times x minus h squared, and then plus k. That part is gone because that's adding 0. In that case, x equals to h is a unique solution, double root, and then we have something like this. b squared minus 4ac is 0, then from that quadratic formula, the square root part is gone, so we do not have the plus minus square root. That's going to be 0 anyway. So we have just one solution like that. Okay, we talked about the general form, vertex form, and then the intercept form. Here are some problems that you have to utilize these. And 1.3 and 1.4 are all about vertex forms. You have to answer, well, find out the vertex, and then minimum, maximum, or range. Domain is always negative infinity to infinity, so you don't have to worry about it. The range is an important one. If you have maximum, if you have negative a value, then you have maximum, and then the range is negative infinity to k. And a value is positive, then you have minimum, and the range is k to positive infinity. And in this case, h and k value are easily obtained. H in this case is negative 1 and k is negative 3, and you can easily find those out. And when you have general forms like this one or that one, you can find out h and k values through these two formulae, h and k, so that's easy. Now, how about these kind of problem, 1.5 to 1.10? All those problems have something to do with finding out a value. Why? In the vertex form, if you are given h and k, or you can easily find out h and k, then from the third condition, you have to identify what a is. Or from the intercept form, if you have r and s, okay, good. And from the third condition, you have to find out what a is. For example, how about 1.5? Symmetric to vertical line x equals negative 2, so there goes your h value. Maximum 3, so there goes k value. And y-intercept is negative 1, so if you plug in x equals to 0, then you're going to get y equals negative 1 as function value. From that, you can find out what a value you're going to get. You're going to get an equation of a, and then you can find out what a is. Well, the detail is left to the students. How about something like this one? You have maximum 3, so that's k value. And then intercepts are 1/2 and negative 5/2. So 1/2 and negative 5/2 will replace r and s there. So you have an equation except for unknown a value. And how do you find out the k value? Maximum or minimum? Well, that's going to be your y value when x is equal to r of s over 2. So you know what to plug in. and that equation will help you identifying a value. Again, I'm going to leave the details to the students. It's not that I'm leaving all this because they are unimportant. I may end up writing this kind of problem in the exam. It's just that we already covered this kind of things well in college algebra or even intermediate algebra, elementary algebra, many times already. So I'm going to ask you to go through all these problems. That's about it. I do not regard these kind of problems, any of these problems from 1.5 to 1.10, unimportant. I'll simply leave the details to the students. How about the last one here? Find an equation of the quadratic function y-intercept and x-intercept. Again, this is going to be an intercept problem. Intercept form, r and s values are -1/2 and then -7/2. And a is unknown, and you can find out a value by y-intercept is 6. Plug in x equals to 0 and y value is 6 in that equation. Again, you can find out what a is. Well, looks like we have a little bit of time, so I can show you just one solution. Let's take this one. Open up. Okay, and then, oops, what did I click? Slow to react. Okay, here it is. Okay, I just gave you the answer here, so it doesn't really help very much. So let's open the previous problem here. Looks like there is a solution process. Okay, x-intercepts are 1 and 5, so we have this kind of equation, and then unknown value is of course a. And then what does this problem say? Minimum is -2, so that's going to be your k value. And how do you find out k? You have to find out h, and h is, well, x-intercept are 1 and 5, so average of those will be h, and function value is k. So plug in h equals to 3 into this equation over here, and y is -2. So what do we have? We end up with an equation of a. Solving that, we get a value, positive 1/2, excuse me. Plug in 1/2 right over here, and then you have positive identification of the quadratic function, the equation of the function. Or equivalently, you can write the vertex equation. Vertex is given as 3, -2. A value you found out 1/2. So we have that. If you're looking for a general form, then all you have to do is FOIL it over, and then you're going to get ax squared plus bx plus c form. Well, okay, that's about it. And the other problems are left to the students.